This week we'll continue looking at atmospheric heights by calculating using a standard atmosphere what we would expect the height to be. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to keep working on our heights problem. If you haven't seen last week's video, go back and take a look at it. But what we've done is we collected a lot of sounding data, and we found what height is the 500 millibar level. Then we made a plot of that, and we saw that there is this expected seasonal trend. So what we're going to do this week is, using the surface pressure at that station, assume a standard atmosphere and see if we get the same result, and if not, why that might be the case. So starting with our notebook that we had last week, we're going to rerun our imports, and in get daily stats, we're going to add a couple of things here. We're already calculating the 500 height. I want to calculate the mean temperature in that 500 millibar layer, so I'm going to use nan mean. Don't forget to use nan mean because there will be nans in your data, and this is a great way to make sure you don't get nan as a result, because if there are any nans in the input, np.mean will just give you a nan as the output. So use nan mean, our df below 500, we're going to look at temperature. In our return, I'm going to return df below 500 height 0, and that's the first height, or the surface height. You could also use minimum here if you wanted. So we could use mp nan min, because we know the surface height is going to be the lowest. We'll also return the nan max of df below 500 pressure. So that's going to be our surface pressure. And finally, our mean temperature that we calculated. So if we run that, we see we've got an issue. Mean t is not defined. So I'm going to interrupt. And we go back up and look and say, well, why is mean t not defined? It's because we had a typo here. All right, now that we've got our returns modified, we need to go down here and modify our code that calls that function. We've got heights from sounding and sounding dates. That's fine. We're going to keep our surface pressures, our surface heights, and our layer temperatures. And we'll modify, since we're returning multiple things from get daily stats, we'll call this height 500, height surface, pressure surface, and mean temperature. Modify our appends here. We've got surface pressure, dot append pressure surface, surface height, append height surface, and layer temp, append mean temperature. We'll run that. Might take just a second depending on your connection and machine. Okay, if we recreate our plot from last week, we see it's there, so we haven't damaged that part of our code's functionality. But we want to actually calculate, well, assuming we know the surface pressure, how far is it to 500 millibars in pressure space, and what does a standard atmosphere tell us about what kind of height that should be? In other words, do we need to factor in this layer mean temperature and have the whole sounding, or can we just measure surface pressure and get good enough? All right, so I'm going to calculate the pressure to 500 millibars. In other words, how far in pressure space from the surface to 500 millibars. That's going to be P minus 500 HPA for P and our surface pressures. And then we can use MetPy to say, from the surface conditions, what is the predicted height? I'll do that with mpcalc, add pressure to height, which takes a height and a pressure, and I want the result in feet so that my plots line up. for a height and pressure in our surface heights and our pressure to 500. So in other words, we figure out how far in pressure space it is from the surface to 500 millibars, and then we're going to add that pressure to the surface height of the station. And if we make a plot of that, remember our Julian day for day of year and height from surface conditions, we see that, okay, maybe in this center part of the year we might see slightly elevated 500 millibar heights, but really this is scatter of about 800 feet in height versus, that's about this much on this plot, versus the very clear trend that we have. So that's telling us that surface pressure isn't telling us the whole story. So what could be adding to that story? And of course, one of the main things that's going to change over the course of the year is the temperature in that column of air. So I'm going to create a plot here using plot.subplots. I'm going to create a twinned axis. On the first axis, we're going to scatter our heights from the sounding that we calculated. On the second axis, I'm going to scatter the layer temperatures that we calculated. And of course, we'll color those red because they're temperature. And we don't want to forget our axis B there because we're plotting on a twinned axis. And there we go. We see that the height calculated, or observed in the sounding rather, is pretty much directly related to that mean layer temperature. So that's one reason we need upper air observations, because the actual mean temperature of that layer does make a large difference. Now, could we factor surface temperatures in and maybe get a little bit better? Absolutely. But just taking a surface pressure reading and trying to determine the height of a pressure level doesn't work so well. I hope that you found this useful, and I'll see you on next week's MetPy Monday.